The concept of this video is more so with solving systems, but now with a focus on substitution, which I'm a little biased on. It is my favorite method to solve, and by far my number one choice. It usually is never students' favorite choice, but it's mine. So let's dive into substitution. So when is it best to use? To be honest, it's when you have somewhere in an equation, there's a variable that is isolated or quickly isolated. So do you have a lonely, we're going to call it a lonely variable, okay? If you have a lonely variable that you could isolate, this is a great method, okay? I would not use this with, everything has a coefficient and there's lots of fractions. I wouldn't. But a lonely variable is a great key. So you are still left with some different solution types, right? You've got, one solution, no solution, and infinite solutions. And so what does that look like? Well, this is, one solution is pretty straightforward. You do the math, you get, let's say x equals a number, and then you have to plug back in to get y, for example. Okay, but one solution would mean you get an x and y value, just like we did with graphing. What does it look like when you do no solution? Well, you start solving your equation, and all of a sudden you end up with something that is very false. Like, let's say, it could be multiple things. It could be 0 equals 10. It could be 22 equals -4. You're just left with an equation that doesn't make any sense. Like, neither of those equations are true. So, and the big red flag I should say here, and I'm going to kind of write it in a red color here, is that the variables cancel. So if you have an equation with no variable, this would be an idea of like, oh, hey, this could be no solution. The opposite would be if your variable cancels and you're left with something true, like 0 equals 0 or 10 equals 10, etc. If you're left with something that makes sense, and again, this is when your variable cancels. If that happens, this is an example of infinite solution, meaning it doesn't matter. If the variables cancel and what's left over is the same thing, then of course it doesn't matter what x is or y is or any other variable, because no matter what, it'll work. Okay, so before we kind of dive into the solving, let's just take a look at what I mean by like a lonely variable, right? So in this first example, you can see y is already isolated and by itself. So for substitution, what you do is you box up what it equals, and you take this rectangle and you kind of plug it in for what it equals. So like you're switching the rectangle and the circle. So flip-flop, and now you've got this equation. What's great about this is you can solve an equation with one variable, but you can't solve an equation with two variables. So I don't know how to solve x and y together, but I do not know how to solve an equation with just x. So that's the goal of substitution. For this next one, the middle column, you can see that the y here is lonely, right? I could quickly move that 10x over and y would be by itself, and then I would plug that expression into this top one for y, okay? And the last one, pick and choose. I would choose where y is positive, because if I move the 2y over, I've got a lonely y right here, and I could plug into this y right there. Okay? So that's kind of the main message here. This is what we're going to be doing. So let's try some examples. So in this first one, you've got y here is equal to this boxed up expression, and I'm just going to flip-flop the two places. So the box is going in for the circle. You have to remember to use parentheses, because you're going to have to distribute, because that 2 is being multiplied, rather -2 is being multiplied by everything that y is. So once we get this, we're going to take that -2 right here and distribute it and solve. And this just becomes a linear equation, right? Something that we have a lot of experience with, that we just have to isolate the x value and we get x equals 1. What I want you to realize, though, is that remember when we graphed, the solution was an x and y coordinate. So this is just an x. We need to actually plug that x value into the equation to solve for y. So I'm going to plug it into negative 6x, oops, sorry, not x, but 1 minus 9. So negative 6 minus 9 is negative 15. It did not matter which equation I plugged into. Either one would work. This is just the one that I chose. You could graph these if you wanted to check it. You could plug both equations in, or both solutions into both equations, and it should work for both. Okay, so don't just check one, check both. Let's try another one. In this one, you can see that the y is almost isolated. We just have to move that negative 4x. So y becomes 18 plus 4x. And now let's plug that into this bottom y. So negative 8x plus 2 times 18 plus 4x equals negative 3. So when I do this, I get, let's see here, 36 plus 8x equals negative 3. Here is our first time where we see this idea of the variable canceling. The x's go away completely, and I'm left with 36 equals negative 3. So if you remember back when we were talking about what does it look like when you get these different solutions, a variable cancels. The question you're asking yourself is, with what I'm left with, is it true or false? And in this case, this is false. 36 does not equal negative 3, therefore leading me to say that this has no solution. Okay? And if you were to graph these, you would see that these would end up being parallel lines, never intersecting. Let's try another one. This one's a little tricky because the y's are both isolated, right? So you're just pretty much plugging in this box into this side of the equation, creating a two-sided equation, which is fun. So 18x plus 35, that's not a 5, equals 6x plus 11. Come on now. All right, so again, isolate the x's. And x equals negative 2. I hope you're saying, don't forget to find the second solution. You're right. Again, it doesn't matter which one. I'm going to choose the second because the numbers are smaller. So I can do that in my head rather than having to get a calculator. So negative 12 plus 11 is negative 1. There's my second solution. I would encourage you to push pause on this next one and try this one on your own, and then push play when you're ready. So there for a minute, if you're following my work, I kind of forgot that the 41 was negative. But when you go through and do this solution, you get x is 1 and y is negative 20. So I hope you're seeing kind of the main message here. Notice that I'm not doing anything where the y or the x cannot be quickly isolated, okay? I would not do this if y had lots of coefficients. This would not be my method of choice. So I would encourage you to try some of these, and if you have further questions, come see me.